Okay. So till last time, I think what we did was some of the additional logic operation. We talked about RLC, RAL, RRC, and RAR, right? And now we further move to other types of logical operation. So the first type is CMP. Please note down, these are very important ones. So CMP is basic function is to compare the contents of registers or memory with that of your contents in your accumulator. So that means suppose you have the contents stored in memory address 4004 or in register B or register C. So this statement helps you to compare with the values that exist in your accumulator. So where similarly your other instruction, which is CPI, which is compare immediate, and that would help you to use this when you compare the 8-bit number to the contents of your accumulator. So the compare instruction sets the flag 0, carry, and sum. So in which all situation you would be doing a compare statement? Plus, anybody? Arvind?
Yes, sir.
Yeah. So where do you think a compare statement would be used?
Comparing the instructions, or like comparing the digits like 5 greater than 4 or anything that like that.
Yeah. So probably when you're talking in terms of programming, which all types of programming would require, say, a compare statement? Chamanpreet Singh?
Yes, sir.
Yeah.
Sir, if we want to match our output to the something that we get, I guess.
Daksh, can you be more precise?
Sir, anything like if else loop or do while loop, we may need to use comparator for that.
Sandeep, more precise, single statement. Sandeep? Premlata? Premlata?
Yes, sir.
Yeah, where do you think? I think a lot of you have given some answer, but not the precise one which I am looking for. So where would you want to use this thing? Your compare statement? Premlata? Am I audible? Anmol? Anmol? You there? Ishan?
Yes, sir.
Yeah, where do you think this compare statement may be used?
Sir, I don't know really. Just to compare two quantities, whichever one is larger or smaller in a way.
Right. So whenever you're doing sorting, I mean like sorting of numbers in increasing order or decreasing order or something on in that fashion, I think you have done basics of C language programming and stuff like that. So you must have done sorting. Aditya? Is that clear? So the compare is done using the internal subtraction that doesn't change the contents of the accumulator. Okay, so it is generally used when you are doing some kind of sorting, whether it's bubble sorting or any other different types of sorting. Then you have different types of branch operations. In particular, you have two different types of branch operation. One is your unconditional branch, while the other one is your conditional branch. In the unconditional branch, it goes to a particular defined location without any condition, no matter what. While in the conditioning branch, it goes to a particular location if the given condition is satisfied.
सर वैसे ब्रांच ऑपरेशन का मतलब क्या है?
Huh?
What do we mean by branch operations?
नहीं Yes, go ahead. Can you repeat your question once again?
Sir, what do we mean by branch operations?
So this is what we are saying. I mean, like when you are when your microprocessor is generally executing your instruction in a sequential form, right? So if you want that sequence to be shifted or broken, the execution of those instructions, you use branch operations. So this, like suppose it is going from state, first to second to third to fourth to fifth to sixth, sequential. Your microprocessor is sequentially executing those instructions. Now, instead of your sixth instruction, the next one that would be followed would be a instruction, say in your lines of code, which is 7. But if you want that to change to say 11th or 12th or 15th, you would use such kind of operations. So these kind of operations are the conditional and the unconditional branches. So the first type of kind of unconditional branch is jump. So JMP. So this basically helps you to go to a particular address. The second type is call. So in this, it jumps to the address specified but treats it as a part of that particular subprogram or your subroutine. And the third one is return. So it returns from that particular subroutine. Is that clear?
Sir, I did not understand the difference between the subroutine, like jump and call branch.
Okay, so jump is basically when you're going to a particular address. So suppose you want to go to 4008, right? And you want to play around with the contents that is stored in address 4008. So it will have, you will use your command JMP. Now, if you want to, you have a kind of a subroutine which is, say, performing, let's take an example of multiplication. So multiplication can be performed by repetitive addition. Okay, so now there is a program which is adding a number, and the instruction of that program is stored in, say, 4040 to 4048, 4040 to 4048. So this is where you would use your call statement. So this call statement, while going for repetitive addition, would be performing this in a loop form, and it will continuously keep adding till the specific condition is satisfied or not satisfied.
This is
So this,
satisfied. Yes.
yeah. So this being an unconditional branch, it would not look for any condition to be satisfied, but would execute this particular subroutine, which is addition. Is that clear?
Yes, sir.
Okay. So the address that one needs to tackle in all branch operation must be, of course, of 16-bit. So this 16-bit would have the lower order and the higher order. So here we may just use register pair H and L. Okay. Now you please note down the different types of conditional branches. Different types of conditional branches. The first one is JZ. The second one is J and Z. So the JZ is basically going to an address when the flag 0 is set to, when your flag 0 is set. The second one is J and Z. Please note down. I mean, like, that's why I'm going slow. So this performs the jump to the address specified if the condition flag 0 is not set. The third one is JC, or jump on carry. Using this statement, it goes to the specified address if the carry flag is set. Next one is JNC. This allows you to jump to the specified address if the carry flag is not set. Then you have JP. So this statement allows you to go to specific address if the sign flag is not set. And JM allows you to go to your specified address if the sign flag is set. That is basically it is negative. Okay? So these are very important instructions when you are performing all kind of arithmetic operation, not the simpler ones, which is like simple addition or subtraction. Have you copied this? These are very, very important ones. You would be using it all over. Daksh,
Yes, sir.
is that clear? Have you copied?
Yes, sir.
Okay, so now we go to the next thing, which is machine control. So once you have written the complete instruction code, you need to inform to the machine to stop executing the program. And that is done by your halt statement. The other types of machine control statements is your NOP, or basically no operation. So this basically is an exclusive type of machine control which allows you to, as the statement says, which basically stops or used for a delay that is required during the debugging of your program. So the second statement, which is NOP, stops to perform any further instructions and is used usually when you want to buy some time or want to introduce some delay, or when you want to replace certain instructions during the debugging process. Now we go to the next one, which is the different types of operands. So the first one is your implied operand. The second one is immediate data. The third one is when you are talking about the operations in the internal register of your CPU. And the fourth type of operand would be dealing with the data content in your particular memory address. So the statement, the first statement, which is like, as you can see, CMA, which is what? It's a compare statement. So here there is not exactly any type of operand. So it is a kind of an implied operand. See the second instruction, which is add immediate. Add immediate. So end user is giving immediate data to be added. And what is that data? 4F. So 4F is in the hexadecimal form. In the third type of operand, where the operation is performed within the internal register of your CPU, you have this register type of operand, like sub B. So what will happen here? The contents of your register B, which would be an 8-bit number, that would be subtracted from the value of your contents within your accumulator. The fourth type is fourth type of operand would be placing the contents in a particular 16-bit memory address, like the statement LDA. So this statement, as we can see, would be loading the value into your accumulator with that of the contents that are stored in the 16-bit address 4000. So if you have an external memory RAM, and in this, you have a particular memory address 4000, the contents of this, the contents that are stored in this particular memory address would be loaded into your accumulator. I think we have already talked about this instruction size.
Sir, what is this is implied of operand implied of?
So these are different types which you would be using. So implied basically means here you're not using any kind of data. You're simply comparing with the value of your accumulator A. While in all the other cases, you are talking with reference to either the data or the contents in the internal registers or the contents in your external RAM, which is pointed by the particular memory address. So the contents of the value that is stored in a, say, memory address 4000, or the contents which is stored in your register B, or if you are immediately giving a value as an external programmer or an end user. So this would be reflected in your accumulator. Well, this you're not giving any kind of external data. You're just comparing with the already existing values within your accumulator. Is that clear?
Yes, sir, it's clear.
So you please also name yourself, because I cannot identify who had asked me a question. So if you have a question, no issues, but you should just, after asking the question, just name yourself so that I know whom I'm talking to.
So it was Manas.
Huh. So we have already talked about the instruction size. So the most important parameter then when we are talking about instruction size is that this is a 8-bit microprocessor. So typically all the instructions occupy 8 bits or 1 byte only. The only exception to this is any instruction that contains immediate data or your memory address, which is beyond this 8-bit. So immediate data will use 2 bytes, while instructions that include the memory address actually uses or occupies 3 bytes. So the first one is generally for your opcode, while the other two is for your 16-bit address. Okay. Otherwise, most of the instruction only occupies 1 byte. So why are we talking about this instruction size? Because this being a 8-bit microprocessor. This means 8085 is a 8-bit microprocessor. So please note down, now we are giving you, making you understand with particular example. So the first statement is like move immediate a comma 32. So what will this do? This will immediately move the number 32 into your accumulator within your CPU.
Sir?
Here the operand is number 32. While your operation is move into your register A or your accumulator A. Yes. Somebody.
Sir, yes. Sir, how is this different from move command, MOV?
It's very different. Move is between your registers or from a particular memory address. This you can give as an external user or as a programmer or an end user. So it is not coming either from any of the registers or from any memory address.
Okay, sir.
When I say memory address, I mean the contents that are stored in a particular memory address. Say example 4000. So the contents, if you want to move the contents that are stored in memory address 4000, you would not be using this instruction MVI. Instead, you would be using different other forms of instructions like MOV, other types of data transfer instructions. Is it clear?
Yes, sir.
Now, if you see, this is one instruction. The first one is your operation, which is move immediate into the accumulator. The other one is the number itself. So what is this representing? This is representing the equivalence of the operation move immediate into accumulator. Do you understand this? This is where, this is what exactly your machine understands. It only understands that when there is a operation that is required by the programmer, in which the operation MVIA is required, it will only happen when its equivalent binary form is introduced to the microprocessor. So microprocessor only understands this. So it is reserved for this particular instruction. Class, is this thing very clear?
Yes, sir.
Yeah. Tell me what did I say just now?
So these binary codes are reserved for this operation, like for this MVI specific operation.
Yes, so the machine only understands zeros and ones. So what is its binary for this type, for MVIA type of operation? It is 00111110. Similarly for all different types of operation, and this is reserved by your by the company that is manufacturing that particular type of microprocessor. So this may or may not be the same if the processor is being produced by different types of companies. Like way back in the 1970s, late 70s, Intel, there were few players like Fairchild, Motorola, IBM, Intel, who were into the microprocessor. So each company may have, not necessarily, may have the same operation and its equivalent binary form reserved, but may have a different binary number for same type of operation. But you can say majority of them had same type, so that there is no confusion. Is that clear? The second
Yes,
part
sir.
the second part is your number. So this is where your end user comes into picture. So what is that? That is 32. So this is reserved. This is already reserved. Move immediate A. Similarly for all other different types of operation. So the machine only understands this, sorry, this, so the machine only understands up to I don't know why it's going beyond this. So up to this or this. Machine doesn't understand anything other than that. So if you write in the instruction in the binary form, it is very much possible. But for simplification, you can also write in its equivalent hexadecimal form, which is the hexadecimal of this is 3e, while the hexadecimal of this is 32. So now we talk about another type of 3-byte instruction. Previously we talked about 2-byte instruction. Now we talk about the 3-byte instruction. So here we are using the jump statement. Jump directly to a particular memory address, which is 2085. Okay, so the instruction is go to address 2085 in your external RAM memory. Okay, so the operation code is jump and the operand here is 2085. So if you want to play or if you want to do any kind of arithmetic or logical operation, say to the contents that are stored in your external memory having an address 2085, you would use this statement. Again, here you can see for JMP, the equivalent binary form is reserved, which is 11000011. Okay, while the other two basically designates the 16-bit address. Is that clear?
Yes, sir.
Okay. So I think we now also introduce the various types of modes or various types of addressing modes that you may be using in your 8085 microprocessor. So what does that mean? Addressing different types of addressing modes. It basically means the different ways of specifying the data for your instructions. Okay, this we have already talked. When we are talking about the implied form, we may use instructions like C and A. When we are talking about giving an immediate value to a particular register, say like register B, we use immediate type of addressing mode. Then LDA, which is like loading the values of the contents stored in say memory address 4000, is a direct type of addressing mode. While LDAX B essentially would be a indirect form of addressing mode. So let's talk about this last one. I think we have already talked in detail about the first three types. Let's talk about the last one. So in this, what will happen? In this, by this statement, LDAX, we are talking about the address pair. We are talking about the pair, register pair, not the address pair, register pair. So this would be storing or loading into your accumulator the values of or the contents of your register B and C. B and C. So this would be loading the value into the accumulator with the contents of the memory location whose address is defined by register pair B and C. So this means when you're using this statement, the value in your B may be, if you want to say again talk of the same particular memory address 4000. So register B may have value 40 while register C may have 00. And the contents of this particular memory address would be loaded into your accumulator. So this is not the direct form, but this is the indirect form. And generally, most of the times you use H and L pair for identification of the external memory address. So I think you must be already knowing about in what all formats your data can be represented, and that you may have done in your previous digital logic or digital electronic class. So you can have it in the ASCII format. You can have it in the BCD format. You can have it as a signed integer or the unsigned integer. So in all these four formats, your 8-bit microprocessor is able to understand and recognize. So most of the times you would be talking in terms of the last three. Anybody, what is ASCII class? Are you there?
Sir, American Standard Code for Information Interchange.
Yes. And BCD?
Binary coded decimal.
Right. So these two. So I think ASCII came at a later stage, but it was initially way back in the 1970s, mid 70s, when 8085 microprocessor came into being. It was only talking about BCD, and as time progressed, you also came up with ASCII. So now your 8085 8-bit microprocessor can deal with both of these. So BCD, signed and unsigned, can be understood by your 8-bit microprocessor. So the data in this can be represented in any of the 4 forms. The other thing I've already told you, whether it's data, whether it's any type of instruction, it is the machine only understands zeros and ones. As I've already said, that each of these instructions that we are talking about is being reserved by that particular company with a particular equivalent binary code. So I think I will not go into this binary coded. You can just take an example. Let's take any number, say 41, all of you, or let's talk about 65 or 82. Please, class.
Yes, sir.
Yes, sir.
Can you
Yes, sir.
represent decimal 41 or 65 or 82 in the BCD format? All of you just
Yes.
write. Yeah, just
Yes.
write.
Yes, sir, we can.
Yeah. Or 120. Please do it right now. In the 8-bit, remember your microprocessor 8085 is only of 8-bit. Once you do this, I would now want you to write an assembly language program. Since we have talked about all the instructions, all the different types of instructions, I would want you to write a program to perform subtraction using second complement. So first you need to convert numbers 65, 41, 120 into the BCD format. The second problem that I'm giving is performing subtraction using second complement. Suppose you have any number that is stored in your register B and another number that is stored in register C. So I want you to perform subtraction and store the value in an external memory address 4000. Please note down this problem. Class, are you there?
Yes, sir. So can you please repeat the question? The
So
last
2 questions. First, I think you should start doing it now. First question is convert decimal number 65 in 65, 41, 120 into its equivalent BCD format. The second question is perform the subtraction of the data stored in register B and C and store the output in the external memory location 4000H. Okay, so all of you start. Manas, have you got the question?
Yes, sir. I'm working on it.
Daksh, Arvind, Aditya,
Yes, sir. Working on it.
Sudhir, Kunal, Kunal,
Yes, sir.
there? Manali, there.
Yes, sir.
Yes, sir.
Sir, first one.
Premlata. Yeah, today I think I just saw 24. What happened? Where are the students? Sparsh,
Sir.
Sanya,
Yes, sir.
Sanya Agarwal.
Yes, sir.
Vrisha Bharadwaj,
Yes, sir.
हो गया?
सर फर्स्ट वाला हो गया, सेकंड वाला कट।
आज 10 बच्चे कम है, 10-12 बच्चे, otherwise it was 32, 33, 34. What happened?
No idea.
Premlata, you there?
Yes, sir.
So I think I will give you a small assignment today itself. Manasa, can you form a Google Classroom? I will give you one or two assignment based on whatever we have done. Now one can start to write instructions. Right now it's for
Sir?
Yes, Manali, you said something?
So
Have you
not
finished?
Manali, I said, so Sanya.
Yeah, Sanya, in fact, you
Yes,
can do
sir.
it. Yeah, I think all of you also perform. First, you perform addition, then you perform
Okay, sir.
subtraction. So the
Okay, sir.
values are in register B and C. First, you simply write a assembly language program which performs simple addition. Store the value in 4000, and then you perform subtraction and then store in say memory address 4004. And once you have done, just let me know.
Okay, sir.
Yeah, those who feel confident can can show me on the video. There is a storing the result in two different locations, having memory address 4000 4000 and 4004, and we generally like we generally write H as this is in hexadecimal form. So why instead of binary we write it in hexadecimal form is basically your programming becomes easier. So we shall be starting with counters and time delay in our next class. That would be followed by subroutines, and then there will be you will reach to a stage where you can write all types of different programs, including like sorting of numbers, writing numbers increasing order, decreasing order, so on and so forth. So as I understand, this will take 2 to 3 more lecture classes, and for your midterm one or your minor test, it would include 8085 microprocessor incomplete in total. Am I audible?
Yes, sir.
Yes, sir.
Yes, sir.
So minor one would be talking about would be questions based on whatever is done till I think 4th of October, right? So more or less we will be able to finish the basics of your 8085 microprocessor. And I shall be giving you probably after, one assignment next week and another assignment just before the midterm 1 exam. So any questions so far? Anything that you want to ask? Have you been able to do this class? Sandeep? 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 I can't hear you. Any problems? Manas?
Sir, I have an answer for third question. The sequential movement like the code.
I didn't catch you. Can you repeat that, what you said just now?
So I have an answer for third question for the addition, sir. I mean, add two numbers excluding PLC.
You have the answer as in you've written the code?
Yes, sir, I've written the code. I've tried. I don't know it's
How
right.
about subtraction using second complement?
So subtraction, I'm not very sure. I've written something, but I'm somewhat slightly more confident about addition that this might be correct. Subtraction, I'm not.
Addition would be kind of very straightforward.
Sir, this arriving at two's complement, what code I have to write for that, I don't know how to arrive at two's complement, the code for that. I don't know.
So first you need to understand how do you perform subtraction using second complement. Accordingly, you can write, you already have,
Sir, I know how.
we have already talked about the instruction to get the second complement. We already know instructions for performing. So you can try, you just see all the instructions that I've talked about, you would be able to do it. I will give you some additional instructions which would further help you to, do programming in a on 8085 microprocessor, and it would cover off most of the aspects. Right now, this is the very basic step: performing subtraction using second complement.
So I have written 3 lines for this. I mean, three lines.
As I told you, for performing subtraction, you do not need to use instruction sub. I would want you to do using second complement so that your understanding becomes better. So perform subtraction using second complement.
Sir, I have one doubt. When we write SUB subtract and the address like C, so in the microprocessor, which kind of subtraction it does, like 2's complement, 1's complement, or the simple subtraction?
Remember, any machine, it only understands what 0 and 1, so it does it by default.
So by default means simply just which method it use?
Huh?
My doubt is what kind of method when we write the code SUB C.
So it will be using the same method. Like internally, it would be only doing simple addition, and so its equivalent form as your sub. It will be doing using the second complement most of the times until it depends on the designer of the microprocessor. So the company would be just saying, okay, why you want to make things complicated. Do it in a simpler form.
Okay, sir.
My idea is to make you understand all different types of instruction sets and tell you exclusively that machine doesn't understand anything other than zeros and ones. So any instruction that you're giving, whether you talk in terms of opcode or operand, everything is boiling down to zeros and ones. So when you're talking about data, that you can change anytime, but they are fixed representation of any all different types of instruction, including move immediate to A or move B to A, sorry, B to C, or move C to B, or any other different types of instruction. For all those things, you can see the reference that is there. I shall also give you different types of, I shall also send you the link. You can check out for each specific instruction, there is a reserved equivalent binary form. How many of you are having a soft copy or a hard copy of Gaonkar? The book I said would be referred most often.
Sir, I have a soft copy.
I also have a soft.
So if you go to the last pages, you would see last pages of the book. I mean, I have not seen the soft copy, but if you go to the last pages, you can see for all different types of instructions is equivalent reserved binary form, which may be also written in the hexadecimal form. And you can share with among your batchmates. Ishan?
Yes, sir. Yes, sir.
You can send the link or share with your batchmates.
Yes, sir. Make sure I do that.
Yeah. And if you go to the, can you open your ebook right away and just let us know for all different types of instruction what is its equivalent binary or hexadecimal code. Like say, if you want to move the contents from register D to E, what is its reserved equivalent in binary or hexadecimal form? Just check it right away. Contents of register D to E. Ishan, are you there?
Yes, sir.
Just check it.
Sir, a second. I'll have to start my laptop up and stuff.
Sir, for the earlier question you have given to subtract two numbers, A and B.
Yeah, go ahead.
So I have tried something in which it's like 7 steps.
You can share it.
I'll just show it. I don't know if it is right, but I'll share that.
Sir, what do I have to check?
I have asked you to perform subtraction using second complement. Storing it, just listen to my question carefully. So you have something stored in register B, something stored in register C. So in the first part of that question is adding the values, adding the contents in your register B and C using accumulator and storing it in, say, memory location 4000H. And then in the other part, which is part B of the same question, you need to perform subtraction. By subtraction, I mean that the contents which are there in register B and register C, you need to subtract them using accumulator. And then what you need to do, you need to store the result in another memory location, say 4004H. Don't worry, I will specifically give you assignments so that things become much better and easier. Yeah, Ishan, have you done?
Sir, what did you ask me for? I didn't get it.
Have you opened your ebook?
Yes, sir.
Can you go to the last pages? Which edition is that? Go to the last pages. You will see.
So this is the 5th edition.
Okay. So if you go almost in to the last pages.
Yes, sir.
What you will see is that for each type of operand, like move immediate A or like MVI A or move B comma C or move D comma E, there is a reserved binary code for each of such instructions. Can you see it from the book?
I'm looking. So there is an ASCII appendix. Is that what you're talking about?
Yeah, in the appendix only I'm seeing.
Yes, sir. I can see it.
You can share it with all your batchmates.
Yes, sir. I'll just put the book in the batch group so it gets circulated.
Yeah. So this is what I'm saying. Machine only understands zeros and ones. This is very important. Otherwise, people are in. I mean, these are basics. Machine never understands anything other than your zeros and one. So for convenience, we talk or write codes in hexadecimal form because it's much more convenient. And then, but still, it is called the lowest level of your programming language. And each company has kind of reserved some kind of equivalence opcode for performance of different types of instructions. And that is indexed and you can see it in the fact end of this book. So can you name few of them, Ishan? Ishan?
Yes, sir.
Yeah, can you name few of them?
A second, sir. Sir, actually, I don't think it's binary that book. I think it's hex that's given in this book.
So that's fine. So you can actually convert it into binary form. Can you name few of them, Ishan? Do it right away.
So there's NOP, LXIB, and there's STAXB,
Yeah.
INXB, all of
What
these.
is the equivalent reserved hexadecimal form?
So 00 is NOP, then there is LXI 11, and there is LXIB for 01, and so on.
Okay. Now, I think you better share this part to the class. All right?
Okay, sir.
All right. Thank you.
Okay. Good afternoon, sir.
Good afternoon.